Today, we're unpacking the energy transition, what it actually means, why so many people get it wrong, and how to think about it without all the noise and emotional heat this topic usually brings. Okay, let's start with the basics. When we say energy transition, what are we talking about? We're talking about a global shift from a fossil fuel dominated energy system to one that's low carbon or zero carbon. It's not just about swapping oil for solar panels. It's about changing what we produce, how we move it, and how we ultimately use it. So what do we produce? Moving from coal, oil, and gas towards renewables and low carbon sources, which is much easier said than done. How do we move it? Upgrading grids, upgrading pipelines and storage systems, and how we use it. Electrifying transport, heating, and parts of the industry. Again, easier said than done. Okay, so here's a key distinction that gets missed constantly. Electricity versus total energy. Electricity is what powers your lights, your phone, your fridge, and increasingly cars and heating systems. But it's only part of the total energy system. Total energy also includes fuels for transport, ships, planes, trucks, heat for heavy industry, steel, cement, chemicals, petrochemicals for plastics, fertilizers, and more. Right now, renewables make up about 30% of global electricity generation and are growing quickly. But renewables are only about 13% of total energy use, and that's growing much more slowly because there's significantly more obstacles in the way. And this matters because you can decarbonize the electricity grid relatively fast, but that's only one slice of the whole energy pie. So if someone's throwing out percentages without being very clear, ask, are we talking about electricity or total energy? Because the answer will vary. Okay, so what actually counts as a renewable? When we talk renewables, we usually mean solar, wind, or hydro. Sometimes geothermal gets mentioned too, but nuclear doesn't count as renewable because it relies on mined fuel, but it's low carbon and often plays a crucial role in low emission scenarios. That's why you'll hear the term low emission sources instead of renewables, which basically means renewables plus nuclear. Okay, so let's talk about the scope of the transition. People hear transition and they often think about building solar farms, wind turbines, but it also means expanding grids to carry all that extra electricity, building storage to deal with intermittent sources like solar and wind, which is a major issue preventing their mass adoption. Electrifying end uses, EVs, heat pumps, electric arc furnaces in industry. Developing low carbon fuels like hydrogen or synthetic fuels for sectors we can't easily electrify. And here's the thing, we're talking about replacing and upgrading systems that took over a century to build, all in a few decades. It's ambitious to say the least. And as we'll explore in a future video in this series, there's a lot of obstacles standing in the way. So, why is there so much misunderstanding when it comes to the energy transition? Well, a lot of the confusion comes from mixing up stats, quoting electricity numbers as if they apply to total energy, as we just talked about, headline chasing, which is a massive problem. New capacity announcements sound huge, but they often just keep up with rising demand rather than replacing any fossil fuels. And emotional bias. People defend their energy sources without looking at the system as a whole. Energy isn't a team sport. You can like solar and nuclear. You can want fossil fuels phased out while recognizing that they're still needed in the short term. Okay, let's talk a little bit about policy. When you see headlines like net zero power sector by 2035 or 50% renewables by 2030, these are policy targets, not guaranteed outcomes. And policies are written in pencil. They're subject to change: elections, lobbying, market changes, public opinion. Just look at the US. They had the Clean Power Plan under Obama, replaced under Trump. The Inflation Reduction Act poured incentives into clean energy, but recent changes have already cut back solar grants and removed certain credits. And it's not just the US. Across the world, changes in government often mean changes in energy direction. That's why projections from agencies like the IEA, International Energy Agency, always base their scenarios on current policies, not wish lists. If you want to judge the likelihood of a target being met, follow the policy and watch how stable it is. So, to recap, the energy transition is bigger than just switching fuels. It's an overhaul of how we produce, move, and use energy. Electricity is only part of the total energy, and the two are decarbonizing at very different speeds. Renewables are a key piece, but they're just one part of a much larger system. And every timeline you hear depends heavily on policy that can change overnight. Okay, this was just a broad introduction. In the next video, we'll look at the big three renewables: solar, wind, and hydro, their strengths, as well as their massive limitations. I also look forward to going over the current fuels that we are depending on and trying to move away from, and the multitude of reasons that will make that an extremely challenging endeavor, to say the least. But we'll save that for another day. I hope this broad overview provided you with something, and I look forward to chatting about energy in our next video.